Hello everyone, Jeff the Green Review here. A large number of Europeans, Israelis, and Australians eat hydroponic vegetables. Imagine not having to wash the soil and other debris from lettuce or spinach leaves. Hydroponics is not new, and in some cold climate countries, greenhouses of hydroponic vegetables are grown year-round. Growing plants using a hydroponic technique is one of the easiest ways to grow many plants. It is growing plants without the soil providing any nutrients. Nutrients are all provided in the water, not the potting medium. The plant still needs to get all of its other needs, light, warmth, air, etc., met in the usual ways. The soil's normal role is to hold up the plant and to release nutrients into the water so the plant can consume them. When a plant is in the soil, the root portion of the plant needs to be large. It must gather water and nutrients in an inefficient and calorie-consuming manner. Hydroponic plants don't waste energy on the root system and can produce more produce. Many hydroponic systems use sterile ceramic rocks or plastic beads to hold the plant in place and to keep the roots damp when the water is not flowing. The hydroponic planting media does not supply any nutrients to the plants. In a hydroponic system, the water and nutrients are provided as often as necessary to keep the plant in the thrive range. The root system can be smaller and still be balanced with the shoots, providing the top with all the nutrients necessary to produce leaves, flowers, and fruit. There will be more productivity in a smaller area over a longer period of time. With nutrients continuously available, the plants grow faster and mature quicker. Another benefit is fewer insect and disease problems. Most problem-causing insects and diseases have some part of their life cycles spent in the soil. No soil means fewer of these problems, and that means better yields and fewer pesticides. No soil also means no weeds. Hydroponics can be done low-tech or high-tech. You can start with a pop bottle or a styrofoam ice chest. For small windowsill plants like herbs that are always being cut down, cut a 2-liter bottle in half and place the top upside down to the bottom. Place a strip of cotton cloth through the top into the bottom to act as a wick. Fill the old top, which is now the pot, with some inert media like perlite. Add a small plant or cutting and fill the bottom with water. This is a capillary system that wicks the water and nutrients to the roots. Another method is to use several gutters on a wall. Install each gutter at a slight angle so each one can drain to the gutter below. At the bottom, there's a reservoir of water. A pump in the reservoir sends water back up to the topmost gutter at regular intervals. The water contains liquid fertilizers. This is a flood and drain system where the roots are flooded with water and nutrients and then allowed to have air and oxygen before the next flooding cycle. Specific fertilizers have been developed for hydroponic use. They must supply all the plant's chemical nutrient needs except for what is received from the air and water. It must be used every time the plant is watered, but very little is used at any one time. Supplying a complete set of nutrients is very important for keeping plants in the thrive range. Fill the gutters with ceramic hydroponic stones or plastic beads that are much lighter than gravel. Because of the smaller root system and continuous feeding, the plants can be set closer than they would be in a garden. Instead of a horizontal gutter or pipe, the same flood and drain system can be used with vertical pipes filled with porous media. Plants are installed in holes or short lengths of pipe sticking out the sides. There are numerous commercially available tray, pot, and barrel systems. You can have a shelf-sized system for a one window or a whole greenhouse system. High-tech computerized water recirculating systems are available that monitor the amount of nutrients and they automatically control the watering cycles. If you don't have a lot of sunlight available, there are several lighting systems that can help. There are specific metal halide, high-pressure sodium, and newer LED lamps available that emit light similar to the colors of sunlight. They can be installed in fixtures that rotate around as though they're on a ceiling fan or that move back and forth in tracks. These fixtures allow for larger growing areas with fewer lights. Hydroponic gardens grow around the same quantity of produce using only about 1/10 of the water as an in-the-ground garden. Water in the soil spreads out beyond the roots and evaporates away, but in the hydroponic system it is recycled. It is one of the most efficient ways to produce food. So what does this mean to me? There are many benefits to hydroponic gardening, but it does require attention to detail. In addition to the normal gardening problems, there are additional concerns like the water's pH, the proper use of fertilizer, the influence that fertilizer has on the pH, the pump filtration, and that the pump stays running, that the timers are working. So there's a lot of little intricate things that you have to get used to be able to make the system work. In this do-it-yourself kit, not kit, but do-it-yourself thing I just did here, we have 3 layers of the stacking trays that we usually use for annual flowers or as a hanging basket system. It's filled with red lava rock. We have 2 different types of lettuce planted in it and Swiss chard at the top. There's a pump down here in the bottom, and we're using the Algo Plus all-purpose food. It's got the NP and K of all being 6, so it's a complete fertilizer that way. And then it supplies at least 8 other micronutrients in the mix here. So that gets mixed into the water that's getting recirculated through the system. In this particular case, I have it running 24 hours a day. I could put it on timer, but I like just listening to the sounds as well. So it's kind of a fountain. And it's pretty ugly, when you get down to it. So if you were going to do this in a place that you wanted to have a little prettier, you would use a different pot than a 5-gallon pot, and maybe even a different stacking arrangement, and maybe add a flower or 2 in there just for the color. Now, you do have to look at the pump. All pumps have a head range that they can't pump higher. So on the side of the pump, it'll say that it does 100 gallons at 1 foot, for instance, or maybe 100 gallons at 10 feet. It doesn't matter, but you do need to know the maximum. So in this case, this pump was about 6 feet, and I don't remember the exact 6 or 6.5 feet, where it says it's the maximum height. And in that case, if I had a stack here that was higher than 6 feet from the top of the water here to the top of the water up here, then I wouldn't be able to get any water. Now at 5 feet, I'd be getting a few gallons each hour, which might be perfectly fine. At a lower height like this, which is only about 2 feet, I'm getting quite a bit of water, more than necessary, but it makes a nice sound, and like I said, and so we're fine with the way it's running right now. So, but I could use a much smaller pump because I'm only pumping up 2 feet. I do have to look at the label and on the pump or in the chart that comes with it to see that I'm at 2 feet how much water I'm getting. So if I'm getting 2 or 3 gallons an hour recirculating through continuously, I only have 3 or 4 gallons of water in here, so that would work out just fine. So look at your pump and look at the height to make sure that they will work for the situation that you're trying to build. And this is Jeff with A Greener View. Thanks for watching.